So I'm Charlie Crocker. I'm from Autodesk. I've been deeply embedded in the creation of our data platform, our big data platform. Autodesk is going through a huge transition right now from selling DVDs of high-end software to having a cloud-based infrastructure for people to do construction, design, manufacturing. We're changing our business model from being selling perpetual licenses to one of selling subscriptions. So it's a very big transition for us. We've been at it for about 5 years. We're getting really close. And as a part of that, we've really started to build out our big data ecosystem. So I want to give you context here first for kind of where we sit, Autodesk sits right now within this sort of ecosystem and where we're headed. And then I'm going to go into some deep detail around what our pipeline looks like, where we have struggled, because we have struggled. I would consider us probably onto phase 3 of our big data platform. We have a very productive and active pipeline, but we're getting to phase 3, and we're starting to really normalize and stabilize that. So I can give you some of the learnings that we've had and where we've kind of moved ourselves through, and we think we're going to be much more successful moving forward. So right now, Autodesk, we've been talking here at the conference. If you were there this morning, people are talking about the revolution in big data. It's revolutions everywhere. Right now, there's a huge revolution in manufacturing and in construction and in how people make things. Whether people are making consumer products, managing cities, working on bridges and large-scale infrastructure, or how they're building movies or automotive, any of these kind of things. They're changing drastically. People are actually building walls, building complete rooms, building the entire ducting systems off-site, and then assembling those on-site. So manufacturing and construction are merging together. You can see up in the top right, there's a little micro factory. This is shortening the supply chain so people can build the things they need right next to the facility that they're at. And 3D printing is also in the process of really changing how we do stuff. And when I say 3D printing, it's not just like printing out these cute little toys. It's things that are bespoke, that are exactly built to your specs, something specific for you, or they could be machine parts. We have a lot of things in the world that are very complex, jet engines, car engines, these kinds of things. More and more of those are being 3D printed, and that's they're able to make things lighter, they're able to make things stronger, they're able to do lots more simulation against those kind of things. Here's a picture of the first 3D printed car, and this is creating a huge disruption in how people design, produce, and the products that we're actually creating. And demand is much more local and it's specific, and people are expecting things to be made specifically for them. So the way our customers are collaborating is changing. People are working on distributed teams, and so Autodesk is working to build the cloud that allows people to do this within the construction environment. Imagine what you can do with infinite computing within the context of construction and design. In the past, if you wanted to create a nice 3D image, or if you wanted to run a simulation to see what the sustainability is of a building or the tensile strength is of some sort of design, you could do 1 or 2 of those and you'd have to use a couple, shut down the office and use all the computers. Now you can put it up in the cloud, run as many as you need to converge on the right solution, not the one that was limited by the technology. So here's just a quick example of taking a form, a shape that was something that somebody designed, and then figuring out how much material can you actually take away to create still a strong product that can be delivered, or potentially even something stronger. And then this is the kind of thing that can then be 3D printed. There are things that can be 3D printed that could not be machined, and this is creating a whole new market. So Autodesk itself, we're focused on the hobbyists, we're focused on the professionals, and we're focused on the production area. So I just wanted to give you a sense. Many people know of Autodesk as the AutoCAD company. This is not where we're at. So big data pipeline, I'm going to talk about that. In the process of us moving from these disks to this cloud-based, simulation-based infrastructure, we've seen a huge uptick in the volume of information that we're gathering and that our customers are gathering, and the work that we can do. Here's an example of a several billion point cloud of the San Francisco Market Street corridor. This is just, one example of, in about an hour, somebody collected a huge amount of data. So imagine the data that our customers are collecting, the products that our customers are using, the people that they're interacting with, the subcontractors. It creates an incredibly complex ecosystem with a huge amount of data. There's so much opportunity for us to create workflows, for us to create value for our customers through the use of this information. All right, that's my Autodesk pitch. Now I'll dive into what are we doing within Autodesk around managing and working with big data. This is my highest level cartoon. People are joking about the data lake, the data ocean, the data reservoir, data puddles, whatever. This is our central repository. For us, it's S3. It's Amazon S3. So we instrument products. We have over 200 products in the market. Products meaning mobile applications, web-based application, desktop applications, and they all, in many cases, work really well together. We need to collect information from these and put them into a common repository so that we can really understand how our customers are working within that ecosystem. We're also collecting business data. What are the transactions people are doing? Which things are they willing to purchase? Which things are they not willing to purchase? What company is this person from? What team is this person from? If they're doing a large construction project, who are the subcontractors and what's the relationship between all the people that are within this organization? That data flows, and some of it's kind of processed into our central data lake, and then we make that data available to all of our different teams within the company. Our goal is to have a single source and deliver value to multiple teams. Now this is hard. We're an older company. We've been around for 35 years, and we have a very startup mentality. We're like 200 startups operating within a large company. So each startup really feels like they can do a better job of design, or they could do a better job, for example, of analytics. And so us getting that information into a common place and being able to deliver a common value is huge for our customers. And then the key goal here for us is self-service, and I'll talk a little bit about that. Tableau, who's my sponsor for this talk, I'll talk about how Tableau fits in and a few other the products that we're using in this context. So at a high level, this is just, I'm giving you like the names of lots of the tech that we're using that fit into different parts of that diagram. But really what we've done here on the left-hand side is we're instrumenting our products. Now, ideally, everybody would be instrumenting the products with our SDKs, but currently there's people sending data to Google Analytics, there's people sending data to Mixpanel, there's people sending data to Flurry, there's people sending data to our systems. So right now I'm doing a lot of evangelism. People talk about data wrangling. I do more people wrangling than data wrangling, trying to get people on board and to start really using the common system. The more we get in there, the more value we're creating. So we currently have around 2 billion transactions, around 350 unique data sources that are pumping data into the system. And we're indexing within the Splunk environment, just as an example, somewhere around 800 gigabytes daily. And this number is a very dynamic number. We're over a petabyte in data that we would call active data. There's more than a petabyte when we think of what we may have in Glacier or a few of the other places that we're storing information. And then we have a lot of different ways that people get access. And I'm not that interested in reducing the number of access points as much as I am in making sure that those access points have access to the same data. And that when somebody does a metric on users or clickstream or funnel analytics, they're not inventing their own because of the limitations of the tool. So that's a key thing for us. Here's just an example of one of the services in our back office. And we're getting around 60 million hits a day. Each one of these little dips is a weekend, so you can really see we're a business app, not a consumer app, because people are using us during the business hours. We released about a year and a half ago a specific type of monitoring tool for some of our desktops, and very quickly we got worldwide coverage and we're receiving a huge amount of volume. And this is just also around one specific product. So these are just to give you examples of the volume. This is not huge volume compared to some companies, but it is still, from our perspective, a fairly big volume. So this is the pipeline. The old way, and this is something I used to talk about and I was really proud of, and now I'm looking at it and going, God, this seems kind of arcane, but I'm going to walk you through it. To get people access to data in Tableau and Datamere and our dashboards and ClickView. It starts with us engaging with a team. We have 200 teams. We have to get them to manually forward their data to Kafka. Once it's in Kafka, we work with them to make sure that their log schema is correct. That could take a couple weeks. Then we forward that data into Hadoop. Then we work with them to define data cubes and all the process, da-da-da-da-da. Then we actually deploy the cubes. And then finally, people get access to this data. So from the beginning of engagement to the end there, I think our best one was maybe 2 weeks with the most engaged team. And there's some teams I've been working with for 18 months, and they're still like, maybe, I might join the party here. So we really have a slowdown. We have bottlenecks in these kind of locations, really, because we're relying on developers to drive the value and to make this happen. So I've got a team of 15 people in Singapore, and they got a long backlog, and that backlog just gets bigger, and that's not a way for us to scale. So I'm going to talk a little bit about how we're starting to overcome these problems around, and one of them is really focusing on transitioning from a bunch of products to services, and also how we're streamlining access to deliver value faster. So the second half of this conversation will really be around these two pieces here. And as you can tell, I'm enthusiastic, and I'm going to go fast because I want to get to the point of us being able to have a bit of a dialogue as well. Okay, so first I said transition to services. So you saw a list of tools. I gave you a long list of tools, Uzi and Kafka and all these things. We're starting to put service wrappers around those and have those become a part of our services ecosystem. So we're going from tools to services. We've had a fragmented architecture with lots of different pieces, and we've kind of had to duct tape certain paths together. We are now streamlining that into an aligned architecture. We're actually bringing the business group and the product group, who actually built out two separate architectures, and creating one common architecture. We're moving from manual ingestion to managed ingestion. So we're not just taking Kafka and deploying it. We actually have SDKs that send the data through our own eventing system, which is built on Kafka. We're going from manual storage, where our teams have to point and decide where it goes and define the metadata and all that, to having automated metadata and storage. And we're going from having lots of different POCs. I use the term YAD, yet another dashboard. Everybody comes home from a conference and they're like, I just discovered the new greatest, best dashboarding tool. And so they want to do it. So for about 6 months, we were doing POC after POC, and some teams would just fund it on their own. And so now we're really working on creating our own dashboarding framework to deliver the web-based stuff. So building services, these have got to be highly scalable, they've got to be secure, very high volume. And then for us, the key thing here is making the onboarding for our teams ridiculously easy. It's got to be super duper simple. So we've created the SDKs, we have a common set of schema, where people know it's secure and trusted, and it keeps the data in our ecosystem. If you send the data to Google Analytics, if you send the data to Flurry, if you send the data to Mixpanel, it's no longer your data. You've just given the keys to your kingdom to a third party, and now you have to, in a sense, get permission and use their APIs to get access. So that's one of the things that we're trying to solve here. So this is just a picture of a lot of the different components of what we would consider our analytics as a service. I don't like the acronym, but it's the best thing we came up with for now. So what we've been able to do is take that long list of all those different buckets there, and if people use our common SDK, they automatically apply the schema, they get put into this catalog, they're put into our security context, it gets stored in S3, and we generate data cubes or data aggregations automatically. So you can, the minute you start putting data in through the SDK, you can actually start viewing the data in one of our downstream tools like Tableau. Now we're going to solve the 80% case, right? There's always an aggregation, there's always a data cube or something that somebody needs special, and we have great tools for being able to do that. But the ability for us to have really taken the development team out of this, they now can continue to improve services. We have a team of 15 Java developers, they're the ones building that pipeline, and they're busy doing data wrangling, data management, this kind of thing. So that's not the right value for them. So Okay, so I know you said this was a Tableau talk. I just wanted to also give you context for how we think about big data and how we're using it within our organization. So now I'll start talking more about access to that data and Tableau. So if that's what you came here for, we'll kind of focus a little bit more on the visualization and the front end pieces. So one of our goals is to really provide access to everyone in the company. I've had this argument with executives. They're like, oh, big data and data, that's really only going to be for the 5 or 10% of the people in the company. And our point of view is pretty much everybody in the company at some level will have contact with the data. And in the future, very near future, our partners and our customers will also have contact with the data. So we've got a couple different things that we're using. At the highest level to get access and delivery to the non-technical users via the web, we've built out our own dashboard framework using D3 and high charts, and we've got that built out internally, and that's a way that we can deliver value to our customers. We also use ClickView. We've used ClickView for many, many years, and so that's something that we have development experience in. When it comes to analysis, the business analysts and the data analysts, we're really using two tools. We're using Tableau and we're using Datamir. We're using Tableau to do the visualization and access all of our aggregations, and we're using Datamir to do some of the exploration and allow non-technical users to run MapReduce queries and that sort of thing. And then finally, we've still got our geeks. We've got the people that are using R, we've got the people that are using Spark and Hive, and those are really our data scientists and our analytic operations people, but there's a lot fewer of those. And what's interesting is the work that the people are doing at the bottom of the pyramid here really feeds the people at the top, right? I mean, if you start defining workflows, you do the exploration, you find something that you want to turn into a canonical or a curated view, then that's something that you can kind of pass up the stream and make it more and more available to the different teams. So I keep saying one source, multiple access points. It's very easy for people in each department to kind of come up with their own numbers that make it really easy for them to sell their point of view. And what our executives are asking for now is for our teams and the analytics teams to deliver the numbers, and then the product teams have to account for the numbers that they're seeing. They don't get to create the numbers anymore. So we have a daily push where we have the data going through the system into our S3 buckets and REST APIs. We put the data into Google, BigQuery, and Redshift, and we're making a transition into Spark. We're looking at Spark as becoming our new fast access layer. There's a lot of reasons for that, but I don't need to go into that. So the data is in Redshift. This would be stripped down data sets. 300 million records, 1 billion records, 78,000 records, something like that. So you're taking the raw data and we're bringing it down to a daily level. So this is really batch. We're not doing, in this case, streaming. This is really batch processing to provide data and value to the widest audience possible. And then we have access tools. You've kind of seen them down the side. We access via Tableau Server and Tableau directly to Google BigQuery, directly to Redshift, and we have now been piloting Spark, and the performance seems to be as good as Google BigQuery and Redshift. Or it's a little slower, but it has nothing to do with Tableau. It has more to do with Spark. With ClickView, we go straight against REST APIs, and those feed our QVDs. Our Autodesk dashboards, this is the high charts framework. We go straight against S3 and Google BigQuery. With Datamir, we can go against pretty much anything, but our goal is to go against our raw data in S3, and then Hive is really Hive on top of whatever your Hadoop is, and for us, that's going to be EMR. And then we have a series of data products. So this is really what everybody cares about. This is what the execs care about, et cetera. So for example, we have an early warning system. We are now able to, through machine learning and predictive analytics, tell which of our customers are more likely to renew or not renew a subscription. You know, this may seem like a simple thing for a company that's born on the web, but for Autodesk, where we've been around for a while, this is something new for us. And so we are now able to contact and work with our partners to make sure that the customers that are most at risk are able to get the attention they need so that they continue to work with Autodesk. We've done some video walls, executive dashboards, and we're working on personalizing product experiences. That's where the real value is going to be coming in, a bespoke experience within our services and within our cloud for each of the customers. So this is just an example. I'm going to show this. This is simple, but this was what was the hook that got me and our data team from being this niche group to being part of the executive dialogue at the company. So just think about that. So we started by in San Francisco, where our headquarters is. We have 9 screens. It's probably about 10 feet by 8 feet, and we put this map and set of metrics for each of some of our main products. We call these data channels. We're like, okay, let's just do this. We put a little iPad next to it. You can click on a product and you can see the data from your product. Now this just wreaked havoc because all of a sudden we were reporting somebody else's metrics. The executives loved it. It got visibility. It's right in a high traffic area. So we've started to then take that. We've created single monitors, come up with a hardware spec, and we're now distributing this worldwide to our various offices, development groups, development teams worldwide. So we're now providing consistent metrics, consistent analytics. Some of them are just vanity metrics, right? But it's getting people to change the way they're thinking about it and working with us. And it's helped us by, we put one of these next to the CEO's office. We put one of these next to the development lead in Tel Aviv. So this is really helping us to get just the mind share around the system that we've put together. All right, I have a couple more slides and then we can have some questions. So at Autodesk, what are we doing with Tableau? We've really enjoyed Tableau Server. We've got about 100 people on Tableau Desktop Professional, and we have about 50 to 60 licenses of Tableau Server. So not every one of our Tableau users right now is connecting to Tableau Server. But on Tableau Server, we've got around 150 or so aggregations that are organized and made available for people, and these are updated on an hourly or a daily basis. And this really allows people to kind of keep up with their information. We really like Tableau because we have data sets in Google BigQuery. We have security, passwords, this kind of thing. I don't have to give everybody credentials for Google BigQuery. I can give them credentials and manage the security using Tableau Server. So that's been has been great for us as we've been starting to grow the usage of that. And then, from Tableau, we're using it to access daily aggregations. We've got general data set workbooks, but we tend to just let people consume their own. And then we've been doing some automated PDFs. Our sales team has worked out some pretty cool stuff where they send out daily and weekly PDFs to like 200 different salespeople, giving them stats on where they are within the week or the month. So we're also testing getting Tableau into Spark. It's already a native connector. You enter in your credentials, and then we already have information we can see in Spark. And the Spark piece can also be set up as either a live connection, or we can have it run as a Tableau extract. And there's reasons to do one versus the other. Mostly it has to do with size. Tableau extracts cannot be super big, and some of our data sets get pretty big. So this is really getting towards the end. What's working for us with Tableau, it's incredibly easy for us to get productive. When we get it in front of somebody who has some Excel background and really an excitement about data, they're really fast to get it. They're really, really fast to get it. If they don't have any background in Excel and they don't, and they're not that enthused with data, sometimes it's a little bit hard to get them on board. But if you've got any proclivity for that, then we've been able to do that. We can connect to our fast access layers. We can connect to Spark. We can make data available and manage access from a common point. Connecting to large data sets is relatively effective if the data set's not in a TDE file. So Google BigQuery has worked really great for us. We get the latencies that work for us, and we can have a billion records and get 5-second response, 10-second response, which is plenty. And we're able to directly publish to Datamere. A couple things that aren't working for us. We have chosen to go with high charts and other tools for the web because we do not want to have every 8,000 people in Autodesk pay the Tableau server fee. TDE files do hit a limit around 8 megabytes, and so we'd really like, so there's just a limit to that, so we end up saying, look, there's other ways of getting access. And then we've just had some difficulty because of the way they sell to different parts of the organization, consolidating our licenses. So we've ended up in some cases purchasing too many, and we've had to get somebody to kind of do the hard work of organizing those licenses. But those are relatively small things compared to the value. We are continuing to grow Tableau in our organization, and we will continue to connect it to Spark and other tools as it grows. So big data right now within Autodesk is really helping us empower how customers are are moving forward into the future of making things. So I want to open it up for questions. Here's my contact information if anybody has just questions in general, and I thank you for your time.
I saw you at the Tableau conference last year in Seattle. So what has changed since that time? I mean, is it evolving?
So he said that he saw me at the Tableau conference, and that was about a year ago. And so what's evolved? So several things. We've really moved out of the tools environment, where at Tableau I was really excited about all those dots. Now we've understood that that's not scalable, right? It was fine because we're growing. We're actually successful. If we hadn't been successful, I could have probably operated that system for the next 10 years. But our success we've had to innovate, and so building these SDKs that allow several of those things to start automating is what I think is the real big change. And we now have a much higher level of executive support. But he's on the mic here. Is that working? Go ahead and just...
My question is, you talked about the managed part of managing Kafka, like there's a manual piece in Kafka, there's a managed ADSK or managed CAC part.
Right.
Are you guys creating like producers in Kafka, or what do you mean by managed CAC for Kafka?
So the question was around what we called the CSE piece. So in the past, we just used Kafka producers, right? And so each service would take the Kafka producer and figure out how to run it and then send whatever they wanted. What we've done now is we've built out SDKs. And so they actually deploy the SDK on their service. It enforces the schema that we want, and then it sends it to our CSE, and that's just, we've turned Kafka into just an eventing engine. So if something hits Kafka, we can send it to 1, 2, 5, 10 other locations, and we've just put our own wrapper on it. Yeah?
Regarding the SDK, so it's a piece that integrates with the client application, right?
Right.
And how do you handle the discrepancy between all the application to fit in your own model? So I think for all applications, you have different application needs to...
Yeah, so there are different applications. So the question is, like, when you have the SDKs, I'm thinking, help me if I get it right, can you really normalize the schema? Are there just so many different ways? And so, what the SDKs that we've currently created are really focused on product usage. And so we're really hitting services, desktop, web, and mobile products in a very common way. And so we've actually done a big schema analysis of all of the data that we've been collecting, and then we've started to normalize that. And there is so much that is the same, in terms of, session IDs and the user and what point did they first hit the application, and is that application connecting? We've built out our own paths, and so our applications are hitting our identity service or our file service. And so it may seem really big, but it's becoming much more constrained. There are always outliers, and we look at those as providing custom schema additions and potentially future additions to the normal schema.
Is it something you develop in the project, or?
Yeah, so we've developed it in-house. We've used a lot of, so we haven't finished our mobile SDK. We've done a Java SDK for our services. We finished a web SDK, very similar to what you'd get if you were doing Mixpanel or Google Analytics. So we're currently asking our products to mount our call next to the Google Analytics call. Go ahead and keep Google Analytics, but start sending to us. And if we can provide you enough value, then at some point you can maybe take Google Analytics away. What?
Are you planning to open source that part?
At this point, I would say no plans for that. We're still just getting it implemented at our place. But I think that's a great concept. If it becomes valuable enough for an organization, like you said, it's a specific schema. So you'd want to abstract that and say, well, if you have a different schema, can you create an SDK that would do that, right? So I like the concept. In the green. Yep.
Is there a reason, are they complementary?
Well, they're complementary at Autodesk at some level, but there are definitely factions. So I'll give you my personal perspective, which is ClickView we already have enterprise agreements. We've had it for years. It's established. So it's quote unquote free for the general user to pick up and use. Right? Tableau's new. Tableau is easier to use. You can get stuff done more quickly than you can in ClickView, but it costs money because we have not set up an enterprise agreement, right? So that's created sort of an interesting bifurcation. The ClickView is what we use for presenting dimensional analysis in a web browser, right? But I'll tell you, nobody's really happy with the user experience, both in how you create the ClickView dashboards and what they look like. But they do deliver enough that we have hundreds, if not 1,000 users hitting ClickView every day. So it is definitely the most used tool at the company, but more for business analyst data, not for all the data that's coming from our big data pipeline. You were right there, yeah.
Yeah, so it's a couple of questions actually. So interesting in the architecture slide. You have Splunk for transport. So to the best of my knowledge, they don't have a real-time ingestion into the Hadoop. That's one thing. Second is you can't scale below costs, right?
You can't scale what?
You can't scale below significant license costs.
Right. So the question is, Splunk is in the pipeline at the transport level. So and it's hard to scale without incurring a lot of cost. Right. So we've been using Splunk, and Splunk is an amazing tool for us to be able to look at data in real time. We probably have 150 developers who just love to go in there and dig through the debug, and this kind of thing. Because of cost, we do manage what data goes in there, and we are actually pulling Splunk out of the transport layer. So when you see this slide in 6 months, Splunk will be one of the tools that our CSE, that CSE thing, sends to for people who want that data to be able to be viewed in near real time, right? So Splunk will become more of a real-time business analyst tool against log files, because it's so great at indexing on the fly and the queries. I mean, our developers love it. The people who do a lot of the research and just try to figure out how we want to mesh and mash data love Splunk. So it's not going away. We just don't think it needs to be in the transport layer.
The second question is, on the reporting side, you've got Tableau, ClickView, and all of these very expensive, right? But Splunk has the DB Connect, right? You could do reporting for free without any license cost. So could you compare and contrast, why Splunk not your visualization tool?
I think fundamentally the reason Splunk's not a visualization tool is it's easy to use, but it's still, you're kind of coding a little bit. It's a command line interface, right? And for your average business analyst, we're moving away from command line interface. I mean, we could do this whole thing with a green screen that just says Spark or Hive, and people could start to find their directory and figure out what their code is. But that's what we're trying to move away from, right? Most of the things you see on the floor here are trying to abstract the command line so that we can do stuff more proficiently. It really has more to do with the fact that we had two teams building their own Hadoop systems when we first started. We had the business side of the house and the product side of the house. I was in the product side of the house, and we found that BigQuery was great. The non-product side of the house ended up saying, hey, look, we already use Amazon, so let's just use Redshift. The product side of the house has 95% of the data. It's huge volumes. The business side of the house, wow, 55 million records, that's not a big data set for us. We get 55 million records in a day, and sometimes an hour, so there's an arm wrestling a little bit going on around there. I prefer Google BigQuery because it's super easy to access, super easy to use. It's, however, not in our VPC, so security and other things are, so everything's got a give and take. We are hoping to be able to move to Spark and just remove that conversation completely.
Tableau, big question on how can you comment on the performance of Tableau against big data versus traditional databases? And also, do you see any degradation with concurrent users going up in the big data?
So Tableau, concurrent users, and kind of performance with big data. So I'll say two things. One, Tableau does, like if you, we use BigQuery a lot, and so when you see when you do a query in Tableau, when you just drag and drop stuff, it feels so easy. But when you look at the code that's created on Google BigQuery, there's a lot there, right? So I'm sure there are things that could be done to continue to optimize that, and it does seem to be getting faster. They now have their own native Google BigQuery connector rather than using just JDBC, so they've definitely improved it, and we've seen that level of improvement. I've seen incredibly slow response times, but it turns out it's something I did in Google BigQuery, rather than something that's actually been done in Tableau. But we definitely start to hit limits when we get to really big data sets. And so Tableau has really, for us, been a tool for looking at prepared data, right? I do not see it as a tool to go look at raw data and to try to start doing processing. There's really no tool. We use Datamir. We love Datamir. Once you do you set up your table, though, all of a sudden it's empty and you have to run MapReduce again. So that might take 5 or 10 minutes, or it might take an hour, right? Or you can choose a tool like Plat4 and you can say, I'm going to put everything in memory, and then it'll be fast. So there's no free lunch when it comes to being able to get at the data. You're going to pay for it somewhere. You're going to either pay a little bit of time, or you're going to pay for a bunch of servers to stick the data up in the cloud and have it sitting there.
How are you using Kafka? Somebody asked a question differently. So how are you using Kafka as your Tableau data source?
Kafka, so how am I using Tableau, Kafka as a Tableau data source? Kafka is not a Tableau data source. Kafka is just, it's our eventing engine that takes all of the stuff we send to it and sends it to the right place to be either injected in the data source or put in Splunk or put in Cassandra for some real-time action or something like that. So it's literally just, it's just, our file tailor. And then once stuff gets into S3 and some processing, and then it becomes available, right? So with Splunk, we can have stuff available within a minute or two of receiving it, whereas in Tableau, we're on a day cycle. So, so that's where Splunk is great for us. Okay, question? Yeah, I love to be Grand Galactic and come in there and say we should just stop doing, we have a bunch of businesses that are running, and they're running using those tools. I can't take those tools out. All I can do is offer better tools and at some point show enough value that then we get something at the high level. So, we finally saw that change where we've decided as a company from the top down, from the CEO down, that we're going to use GitHub. Right? Until then, we had, different repositories in a variety of different places. And when push comes to shove, GitHub will still probably only cover about 60%, right? So, we're a big organization. We're not going to just, if we were a startup, I'd be like, pivot, right? We're all going to go here. It's cheaper, or it's going to add more value, or something like that. But for Autodesk, it's, this has been 18 months, and it's been all people wrangling skills to kind of even get where we are today.
The Tableau connection to Spark works nicely, I guess.
Yeah, the Tableau connection to Spark works great. What we're finding, and I had a benchmark survey I was going to put up here, we benchmarked Google BigQuery to Tableau. Not Google BigQuery to Spark, not in Tableau, but the performance is similar, and Spark is about 50% slower. But when you're dealing with 2 or 3 seconds, it's like, okay, the same query of 300 million records using Spark was 4 seconds, and using Google BigQuery it was 2 seconds, or something of the sort, right? So we're still dealing with like under 10 seconds, and for some of these, when you're dealing with big data, 10 seconds is okay. That's not enough time to go get coffee,
In that case, Tableau will do more than just dealing with process data. You earlier said Tableau did.
Yeah, it can, but it also depends on, with Spark, we're still learning. I don't know enough yet. My engineers know more about it than me, but we have to deal with whether or not the data is cached. Did we cache it on disk or cache it in memory? Is it the first query the first time you open Tableau? Is it the second query and something's already in memory? How did you partition your query? There's so many different things you can do to tune that we're going to have to figure some of that stuff out. All right, well, one more.
So why are you planning to use Spark?
Why are we planning to use Spark? Let me see if I can help channel my... Here, I'm going to find that one slide, because I think... Here you go. So this shows the benchmark of Spark queries in seconds, and then GBQ queries in seconds. So it kind of gives you there. So these are the reasons right now that we're thinking of using Spark, okay? Google BigQuery doesn't use our metastore. Redshift doesn't use our metastore. We want to have a consistent security framework. That's one of the reasons that we want to use it. Spark does the ETL, the fast access, the data, all of these things. If it really does deliver on that, then we don't have to have multiple storage solutions. With GBQ, no, that doesn't really matter. And Spark works directly against S3. So we can have the data available immediately rather than having to go through processing and pumping it into Google BigQuery. So these are some of the reasons why we're talking about going to Spark. We are in the process of doing it. I'm the naysayer right now. I'm like, that doesn't look like a performance improvement to me. These are my engineers sending me this. I'm saying, that doesn't look, I'm not happy with this. So, I'm not killing Google BigQuery until they figure out, what the caching scheme is or whether we have better partitions or that kind of thing. But this is really our why Spark slide. How are we doing with time? Good? All right, well, thank you very much. Feel free to contact me.